All right, so the second lesson in organic chemistry will be cycloalkanes and alkyl halides. So basically, this is an extension of the previous class. We are going to still name alkanes, except now this time they form a ring, so a cycloalkane. And then also we're going to name alkyl halides, so basically alkanes with halogens attached to them. And we're going to learn about reactions of alkane to make alkyl halides. So first off, a little review. I just need to make sure that you know how to name normal alkanes before we continue. So I'll give you 3 minutes on these, and then I'll take them up just for review. All right, cool. So taking these ones up, the first one is relatively simple, but it has a tiny trap. The longest chain is actually 7. Okay, you can't just go across. You gotta bend down. So that would be 2,3,5 trimethylheptane. They're all methyls. There's no ethyls in here. The second one, that one looks funny, but you still have to follow the rules. Find the longest chain, and the longest chain is a pentane, and there's 2 methyls. 9 carbons for the longest chain. In the middle, you have a 6-ethyl, 2,7,7 trimethyls, 5 propylnonane. So keep in mind that you have to count from the right side. Okay, from the right side, you get a 2. If you count from the left side, you get 3,3. 2 is preferred over 3,3. Does that make sense? You must count from the right side. So this is 2,7,7 trimethyl. Okay, I hope you got the same thing. All right, so let's move on to cycloalkanes. So a cycloalkane is just an alkane that forms a ring. To name, you simply add cyclo before the name of the alkane, and that's it. Okay? Keep in mind that the ring is always the backbone. It doesn't matter how many carbon the ring has, it's always going to be the backbone. It doesn't matter how long your substituent groups are. Okay, and also you have to number the carbons just like before, and so that all of the substituents have the lowest possible number. So let's look at some of these examples. The first one, a 5-carbon ring. That's quite simple. Cyclopentane. Okay, pentane for 5 carbon, it's in a ring, so cyclo. The one on the bottom is a triangle. In math class, it's a triangle. In chemistry class, this is cyclopropane. All right, 3 carbons bonded to each other in a ring that must form a triangle. The one on the right, you have a 6-carbon ring with a 7-carbon tail. So in this case, your branch is longer than your parent, but that's okay because your parent is in a ring. So you would have heptyl cyclohexane. Okay, heptyl because you have a 7-carbon branch, cyclohexane, that circular 6-carbon ring. So do we have any questions regarding naming cycloalkanes? All right, so these are the simple ones. What about these guys? All right, if you were to name these folks, if you have sometimes more than one substitution. So for the first one, it's quite simple. You have 1 branch on a cyclohexane. So what is the name of the first one? Anyone?
2-methyl cyclo.
Wait, so what did you say? 2-methyl?
Yeah.
Where'd you get the 2 from?
You always start from the first or the second.
You always say, which one is the first one? Like it seems like you just arbitrarily decided that you're always going to be the first one, so that one's the 2. You see what I'm saying? You're right, it's methyl cyclohexane, but I don't know where you're getting the numbers from. It's methyl cyclohexane without a number. Because, well, what is the number? What carbon is it on?
1.
1, obviously 1. It has to be 1. It doesn't matter where you move the branch. It's always going to be carbon 1. You see what I'm saying? If you move it, well, we'll just redefine what carbon 1 is, and it's going to be the one with the branch. So you don't need the 1. That is redundant because it's always going to be carbon 1. So writing the 1 is a waste of time. So we actually don't write the 1. So it's methyl cyclohexane. For the one on the right, though, because you have 2 methyls, now you do have to specify the numbers. So that would be 1,2 dimethyl cyclohexane. Okay, you do need the 1 this time because, well, you got to tell me that it's 1 and 2 because they're not on the same carbon. You see what I mean? The third one, what would the third one be? If you know how to do the second one, what's the third one? Folks?
1,3 dimethyl cyclohexane.
Yes, exactly. Same as the previous one. Instead of being 1,2, you are on 1,3. Okay, it's 1,3 because the 2 methyls are just 2 spaces away from each other. So if you just label any one of them as 1, the other one must be 3. Okay, it doesn't matter which one you label 1 because you're going to get the same answer. It depends on which direction do you count. You obviously count in the direction where you can have the smaller number. In the last example on this page, they're on the same carbon. So you have to say 1,1-dimethyl cyclohexane. You must specify that it is on carbon 1 because you have 2 of them. All right, if you just have 1 of them, you don't have to tell me because it's obviously on carbon 1. But when you have 2 methyls, it's not obvious that they're both on the same carbon. They could be on different carbons like the previous 2 examples. You must specify which carbons do you see each of the branches. So you have to say 1 and 1, okay? All right, so knowing this, do these 2. So example 2, you have 2 more cyclos. Just tell me the name, and I'll give you 2 minutes, and then I'll take this up. All right, so for the first one, you have 8 carbons in a ring, and you have 2 substituents. So 2 of them are methyls. So obviously, you can only do this in one way. You just arbitrarily pick one to be your first carbon. See, it doesn't matter which one you pick to be your first carbon because you can just change the direction to always get 1 and 2. Okay, I just happened to choose the one on top, and I went clockwise because I chose the one on top. If you choose the one to the right, then you just have to go counterclockwise, and you should still get 1, 2. So that means, well, first we have a cyclooctane. So 1 methyl, 2 methyl. Put that together, you have 1,2 dimethyl cyclooctane. Okay, there's the double O in cyclooctane. Normally, if you would pronounce it cyclooctane, because double O is oo, but you know it's chemistry, so it's not English. You gotta have to pronounce it as cyclooctane, and you must have the double O. Okay, next one. Which one is carbon 1? The one on top or one to the left? Top. Did you choose that one because you had a reason, or it didn't matter?
I mean, I chose the top one because there were 2 like methanes. That's why I was thinking like maybe that one is more like it makes more sense to me. I don't know.
Well, yeah, you're right.
Oh.
You chose the one on top because it had 2 methanes instead of 1, right? Remember, your goal is to have the least set of numbers, the smallest set of possible numbers. If you do this, if you just choose the one on the left, you have 1, 2, 2. Okay, whereas this one, if you choose the one on top to be carbon 1, you have 1, 1, 2, but then you have to go counterclockwise. And of course, 1, 1, 2 is smaller than 1, 2, 2. So there is a definitive answer, okay? It does matter which one you choose. It's not a 50-50 probability. You have to choose that one. So once you choose that one, it's a cyclopentane. You have a 1-methyl, and another 1-methyl, and a 2-methyl. Just putting everything together, and that will get you 1,1,2-trimethyl cyclopentane. All right, so is that clear, guys? So make sure you always choose the one that gives you the smallest set of numbers. And if you have two groups on one carbon, you should probably pick that one. All right, so let's move on to the next part of the lesson, which is alkyl halides. An alkyl halide is basically an alkane with halogen. Okay, you substitute one or more hydrogen with different halogens. And to get that, you need a substitution reaction. And as the name would suggest, substitution means you do a switch. So if you look at the diagram, you have an ethane molecule. One of the hydrogen will be substituted with a bromine. So if you combine the ethane gas with bromine liquid and you apply heat or ultraviolet radiation, you will eventually substitute all the hydrogens for a bromine. So you start with one and you get bromoethane, and the bromine becomes HBr. But because you have many bromines mixed together, and this will continue until all of them have been substituted with bromines, and you would just get HBr's as the other product. Okay, you must have heat or UV light because alkanes are stable. They don't typically react. So if you want them to react, you have to apply a lot of energy in order for the reaction to occur. So this is what we mean by a substitution reaction. You switch. Okay, H is switched for Br. And we're going to learn how to name what we call alkyl halides, alkanes with halogens. And the names are, well, the naming rules are very simple. It's just exactly the same as the one we've learned, with one key difference. And that difference is, well, if you have a halogen, you just have to name the halogen. How do you name the halogen? Well, if you have a halogen that ends with INE, which all of them do, you just cancel that and you change that to O. All right, so if you look at the table, fluorine becomes fluoro, chlorine becomes chloro, bromine becomes bromo, and then iodine becomes iodo. All you have to do is add the O. Second, you have to number them, just like before. Same rule, smallest possible set of numbers. And also, if you have more than one halogen, and just like before, you have to use a prefix di, tri, tetra to specify the number. Now, if you have a mix, like we've learned just alkyl groups in general, if you have a mix of alkyl and halo groups, none of them are, you prioritize none of them over the other, meaning that they're all the same. So the tiebreaker is alphabetical order. Okay, you start with the one that is highest on the alphabet, and bromine is probably going to be the highest because it starts with B. So you go bromo first, and then chloro next, ethyl because ethane starts with E, so you mix them. Okay, and that's it. Oh, also, one is not used if there's only one possibility. Okay, just keep that in mind. You don't put a 1 if you can only have one possible arrangement of atoms. So let's look at some examples to see what I mean by the rules. So for this page, you have 4 different examples, and I know they look weird because I'm using skeleton structure for something very simple. The skeleton structures are useful for complicated structures, but for something like a methane molecule, well, you can't actually do a skeleton structure for methane. That is just a dot. That makes no sense to just draw methane. But this is not methane. You have 1 carbon, 3 hydrogens, and a chlorine. The first one, CH3Cl. The name of this, well, you have 1 carbon, so methane. The only substitution you have is a chlorine, so you have chloromethane. Okay, is that clear? You don't have to tell me that this is 1 chloromethane. Why not? You can only put it on 1 carbon because you have 1 carbon. So it's redundant to say 1 chloromethane. It can't be any other way. So you drop the 1 to say chloromethane. Does that make sense, guys? So the second one, when you have 2 chlorine atoms, Then you have to tell me this is dichloromethane. Di meaning 2 chlorines. You still don't say it's 1,1-dichloromethane because you have 1 carbon, of course, is going to be on carbon 1, so that's redundant. Okay. For the third one, you have CHCl3. 1 of them is hydrogen, 3 of them are chlorines. You can pretty much guess trichloromethane. Again, you don't need the 1 because 1 carbon only. And the last one, you have all of the hydrogen substituted for chlorines, tetrachloromethane. Now, notice that you can name this in a different way. In grade 10 and 11, we learned normal naming. And if you just give this question to a grade 10 student, they're going to be like, hey, look, this is a molecular compound, and I learned that I have to use prefixes. So carbon tetrachloride, which is correct. This is carbon tetrachloride, except that's a grade 10 method of naming, which is equally right. It's just that now we're learning organic chemistry. We're going to be using the organic names. Okay, so this guy has 2 names. Because this is organic, it has an organic name and a normal name. The normal name is just the IUPAC in grade 10, carbon tetrachloride. But the organic IUPAC name is tetrachloromethane. They're equally correct. I'm going to be using the organic name because for consistency purposes, we're doing organic chem, so I'm going to go with that one. All right, does that make sense, guys? This one, you have ethane instead of methane, so 2 different carbons. For the first one, let me just ask you, do I need the 1?
Yes.
Yes, because there are
Because
2
it's
carbons.
right?
2 carbons, so it could be 1 or 2, right? You got to tell me which one. Can it ever be 2 though?
No.
No. If you just take that fluorine, you stick it on the other carbon, well, that carbon will become 1s. So you will always have 1 despite having 2 carbons. You see what I'm saying? So if you have just 1 substitution, you don't need the 1 because it's got to be on carbon 1 by definition. So this is fluoroethane. That's it, no 1s. But what about the second one? Do I need the 1 for the second one? If you have 2 substitutions.
Yeah.
Yes. In this case, you do. Why? Well, because you need to distinguish this from the third example. Okay, this one is 1,1-difluoroethane. You got to tell me it's on carbon 1 for both of them. Because they don't necessarily have to be both on carbon 1. You could have 1,2-difluoroethane. If you don't say 1,1 or 1,2, I won't know which one. So now you must specify the numbers. Okay? So please make sure that you use logic to figure out whether you need to write a number. Sometimes you do, sometimes you don't. Just think about, is there ever an ambiguity if I don't? Okay, and the last one, you have 3 fluorines and 1 hydrogen. Which one is carbon 1?
Right.
2.
The one on the right. Okay, the one with the 2 fluorines. Correct. Okay, it does matter which one you label as carbon 1. It does make a difference. So if you label the second carbon as carbon 1, you have 1,1,2-trifluoroethane, okay, which is superior to 1,2,2 if you pick the first one as carbon 1. You see what I mean? Because 1,1,2 is smaller than 1,2,2. So it does make a difference. Let me just reiterate. You always have just one correct answer. You will never have a dilemma. Okay, one of them is clearly better. So always pick the only right answer.
I have a question.
Mm-hmm.
For the first one, does fluoroethane need to be capitalized, or does it not?
No, because when I type, I have a habit of just capitalizing the first letter. Even if I didn't, the autocorrect would just capitalize that for me. So when you name, well, that's a good question. When you name, if the first letter happens to be a letter, you can choose to capitalize or not. And if I begin a sentence with that, I will capitalize because of grammar. But naming does not require you to capitalize anything.
Okay.
In fact, you can't just randomly capitalize for no reason. Okay? It's only acceptable to capitalize the first letter if it is a letter. Fluoroethane, if you decide to capitalize the E in ethane because, that starts a new word, you can't do that. You will lose marks because this is one word. Okay. And it begins with a number. You're not going to capitalize anything after that. You can only capitalize the first one.
I have a question.
Yeah.
Why is it ethane in this?
Why is this ethane?
Yeah.
Because it has 2 carbons. Do you see the 2 carbons?
Okay.
Draw that for you. There's a carbon right here. There's another carbon right there. See, the corner and the end represent carbons.
Okay.
So you're asking, well, how is this different from methane? Look, methane has 1 carbon right there. And if you look at the second one, well, it has 1 carbon right there. You see what I mean? So yeah, it does get confusing if you draw a skeleton structure of small molecules because you're not used to seeing small molecules this way. Yeah, I drew that because the program I'm using, Marvin Sketch, is very convenient, so I just used it. And plus, I kind of wanted to see the weirdness of a skeleton structure for a small compound. So you do have to know how to recognize them. Of course, it's easy to just draw the normal Lewis diagram, but it's hard for me to do it on a computer. All right, so let's do the practice questions. I want to do the first few together. The first one, that's a very simple one. What is it?
Bromomethane.
Yes, bromomethane. Done. Okay, that's all you need. Bromo because of the Br, methane, you got 1 carbon. This is identical to one of the example questions, except it had a chlorine. This one is. Folks. What is it to think about? You have 3 carbons and a bromine.
I have a question for this one.
Okay.
Do we need to specify like which one, like where the bromine is? Like,
okay, so that's the trick.
yeah.
It's 1 bromopropane. If you said bromopropane, you would have gotten it wrong.
Yeah, because I said 1 like bromopropane, but I wasn't sure because like there was no like specifying like I don't
Yes,
have.
whenever you're not sure, do I have to specify a number? So just ask. If I don't specify, would there be an ambiguity? Okay, let's say you don't specify. But what if the bromine is on the middle carbon, right? How do you distinguish between those 2 structures? So you do have to tell me that this is on the first carbon, because when you have 3 different carbons, it could be on carbon 1 or carbon 2. You see what I mean? But never on carbon 3, because if it's on carbon 3, you still have 1 bromopropane. You see what I mean? For 2 carbons, you don't specify because you can't be on the second one. You just call that the first one. But when you have more than 2, you have to tell me the 1 because it could be 2 or 3 or any other one depending on how many carbons you have. So that's a trick question. I'm glad somebody asked. The next one is very weird. Just take a moment to try to figure out the name, and once you do, please tell me what that is. Anybody?
I found it, but it's so weird.
I know. Hey, what is it?
I said 1, 1, 1, chloro, and then 2, 2, 2, fluoroethane. No.
Okay, that does sound ridiculous.
Oh wait, trichloro. Sorry, trichloro.
There you go. Yeah, okay. So now you're right. You're right. It's 1, 1, 1 trichloro, 2, 2, 2 trifluoroethane. I know that's ridiculous. Why? What? This is as simple as it gets when it comes to the naming. Okay, all of these things present serve a purpose. You can't just not include any of them. There's 3 ones. 1, 1, 1. Why do you say 3 ones? Why can't you just go 1 trichloro, right? Well, the 3 ones tell me that the 3 chloros are all found on carbon 1. Because you can mix and match. You can have 1 chloro on carbon 1, 2 on carbon 2. That would be 1, 2, 2. You see what I mean? So the 1, 1, 1 is just a combination. They all happen to be on carbon 1. Same thing with the 2, 2, 2. The fluoros don't all have to be on the second carbon. They could be mixed. But I have another question. Why did you choose chloro to be carbon 1 and not fluoro? Was there a justification or you just chose one?
C more alphabetical order.
Alphabetical order? Well, that's just it. This wasn't a random choice. I didn't happen to choose the carbon because I didn't choose chlorine because I just liked that one. No, you had to choose that one. You had no choice. Not because it came first. Again, the chlorine just happens to come before the F in this particular expression. You can just flip that 180 degrees and the F will be on the left side, exactly identical. But you must choose chloro to be carbon 1 because of alphabetical order. It doesn't matter for the set. Okay, you will always get 1, 1, 1 and 2, 2, 2. It doesn't matter which direction you count with. So you have a tie. Okay, if fluorine was number 1, then you will still have 1, 1, 1 and 2, 2, 2. So you must have a tiebreaker. And the tiebreaker would be alphabetical order. Okay, you see what I mean? So there's always a clear winner. You will never have to make a tough decision to pick one over the other because you like one over the other. It's kind of like the World Cup of soccer. If you watch the World Cup, if you want to advance to the next round, well, you have to win. So the first thing they look at is points. The most amount of points advances. If you have a tie, then who gets to advance? Well, you look at the tiebreaker, the goal difference. Who scored more goals and conceded less? If that's a tie, I think you just look at head-to-head who won the match. So there are different tiers of tiebreakers. You only use it if that's necessary. Do you see what I mean? The first thing, the only thing that you care about, if you can just decide with that one, is lowest set of numbers. Okay, which direction of numbering will give you the lowest set of numbers? You just pick that one, done. If it happens to be exactly the same from both directions, you go with alphabetical order.
Yep.
Which direction do you number this from? The left or the right?
The right.
The right. Why do you say that?
Because chlorine. No, wait, wrong. Then left. Never mind.
So from the left then?
Yeah.
It's kind of confusing because oh wait, I think it's left because of the bromine, like the alphabetical order. No?
Yeah, no. You're right, it's from the left. Okay, you definitely count from the left. So let me just show you the 2 ways of counting. Nothing to do with the fact that it's a bromine. No alphabetical order for this one. Because remember what I said. The first thing you look at is the lowest set of numbers. If that settles it, you're done. You only look at alphabetical order if that doesn't settle it. If it's equal on both sides, then alphabetically. But if you look at this one, if you count from the left, you have 1, 2, and 5, right? If you count from the right side, you have 1, 4, and 5. So obviously 1, 2, and 5 is smaller than 1, 4, 5. You don't care what the branches themselves are. It's just where they are. You need the smallest set of numbers. So you must count from the left side to give you 1, 2, 5. Yes, chlorine is before iodine alphabetically, but you never got there. Okay? The lowest number settled the score. So you count from the left. Does that make sense?
Yep.
So once you get here, you can just start naming. Well, 5 carbons pentane. So 1 iodo, 2 bromo, 5 chloro. Alphabetical order when you arrange them in the same name. B before C before I. So 2-bromo, 5-chloro, 1-iodo-pentane. Is that clear, folks?
Yep.
When you learn multiple rules, you tend to get them mixed up. Okay, so you have to be very clear. What do you need to do? You have to be clear about the rules. So I have 2 practice questions. I'm going to give you some time. I'll take these up in 3 minutes. Okay, so for the one on top, you have a condensed structure, but this shouldn't matter. If you count, you have 1, 2, 3, 4, 5, 6 carbons. All right, it's the direction that you have to count. That's the issue. So which direction do we go? Left to right or right to left?
Left to right.
Okay, left to right. I hear some messages. Hold on, let me just check. No? All right. Well, yeah, you go from left to right because if you go from left to right, you have a smallest of numbers. So you have 2, 2, and 4. But if you come from right to left, you would have 3, 5, 5. So that's bigger. Don't use that one. So now you can just start just telling me what the names of the branches are. So 2-iodo, 2-bromo, 4-methyl. Put them together. B before I, before M. Yeah, I think I got that right. So it's 2-bromo, 2-iodo, 4-methyl hexane. Now sometimes the letters might get confusing. You forget which one comes first. You're just gonna have to sing the alphabet song. For some letters, some are obvious. Like I know B comes before I. It doesn't take a genius to figure that out. But if it's like, I don't know, J versus L, I really don't know. I have to sing the alphabet song to figure that out. So I don't know about you, but I or M, I know I comes before M. But if you don't, you know what the song is. Okay, so the one on the bottom, you have a ring. Who is carbon 1? Louder, please.
Bromine?
Bromine. Now, is there a reason that you picked bromine?
Because you need to start with bromine because it's like the beginning of the alphabet, so then it would be 1, 3, and 5. 1, 5.
Okay, so you said that bromine was early in the alphabet, so you go 1, 3, 4, 5. Okay, do we have another answer? Anyone come up with something else?
I said chlorine was 1.
Chlorine? Okay, why chlorine?
And then it goes like counterclockwise. Because you have 1, 2, and 3 then.
So you have 1, 2, and 3, and then bromine will be 5.
Yeah.
So which one is it? And why not iodine?
Or iodine, I guess. And then you can go clockwise.
Okay, like you have to make up your mind. You can't pick 2.
I don't know.
All right, so there's only one answer. Okay, always only one answer, and that answer is chlorine is number 1. The reason is you have to have the smallest set of numbers above all else. Okay, and if you choose chlorine to be number 1, you can have a 1, 2, 3, 5. This eliminates bromine. You can't have bromine as number 1 because you would have 1, 3, 4, 5, which is bigger. You see, that's why bromine is not number 1 despite being higher alphabetically. Why not iodine? Well, if you choose iodine, you can still get 1, 2, 3, 5, the same set of numbers, but alphabetical order would put chlorine before iodine. So you first satisfy the smallest number first, and then you satisfy alphabetical order. So this makes chlorine the only choice. Okay, there's always one choice. You just have to use your logic to reason that out. So this is the only way that you can number these. You have to go counterclockwise from chlorine. And 6 carbons makes cyclohexane. That's 1 chloro, 2 methyl, 3 iodo, and 5 bromo. So alphabetical. B before C, before I, before Do we have any questions? Okay. I have 3 more practice questions. On this slide, I have 2. On the next, I have 1. I'll give you, I don't know, around 8 minutes to complete these 3, and then I'll take them up together. Okay. The last one is especially hard. Oh, we did this one. All right, here, this one. The one on top, the longest chain is this one. Okay, if you count it just horizontal, if you count horizontally, you will still get the longest chain, 8. But the reason we don't do that is because if you just count horizontally and get 8, how are you going to name that carbon on top of a branch? I think that was Cinemas's question. You don't do that. You avoid that situation. So that's why you have to go down to make sure that the chlorine is attached to the parent function. Did I just say parent function? The parent chain. Does that make sense? And this is the only way such that the 4 branches are all attached to the parent chain. All right? If you choose any other way, you can have a branch on top of a branch, and that is just more difficult to name. And we always choose the easiest name. But which one is better? Do you start from the bottom or do you start from the right? Which one?
Bottom?
Right.
The bottom. Oh, I hear a right. Well, why do you say bottom, the one that said bottom?
Because when we start from bottom, we have 1 and 7. Oh, wait, yeah. Like when we start from the bottom, we have 1 and 7 for like both chlorides. But if we start from right, we start from 1 and then the end becomes 8. That's why.
Okay, so Eric, what did you say from the right?
You have 2 chloro and 3 methyl.
Oh, okay, I see your reasoning as well. You either have 1, 6, 7 or 2, 3, 8. Which one do you pick? You always pick the one with the 1, okay, the lesser number. Okay, 1, 6, 7. Despite the 6, 7 being very big, it doesn't matter because you have a 1.
All right.
And this is preferred over 2, 3, 8. Okay, just remember that. So sometimes the numbers are not obvious. So in that case, it's very simple. Pick the one with the smaller number. All right, so you pick the one that starts from the bottom. 1, 6, 7 is preferred. Once you have that, you just start labeling. So, well, that's octane, 1 chloro, 4 propyl, 6 methyl, and 7 chloro. So alphabetical order, C, M, and then P. You get that. So it's 1,7 dichloro, 6 methyl, 4 propyl, octane. folks. There is a definitive carbon 1. If you're having a hard time making a decision, I think you just got it wrong.
The bottom one, like, does it matter if we like read it from the right or left? Because I feel like it's the same.
Yeah, because this is symmetric, you can just flip it and it will be the exact same thing. So it doesn't matter if you read from the right or the left. Counterclockwise, clockwise, it shouldn't matter. So I guess this one is hard because, you know, the numbers is always going to be 1, 2, 3, 4, 5, right? There's a branch on every single carbon. So how do you decide which one is carbon 1 if that's the case? Well, remember I said that if you cannot settle this with the lowest set of numbers, you go to the next decision maker, which is the alphabetical order. You have chloro and you have ethyl. Right? 4 of them are ethyls, 1 of them is chloro. Alphabetically, chloro comes before ethyl. So that's carbon 1. That's it. The chlorine has to be carbon 1 because alphabetical order. You're always going to get 1, 2, 3, 4, 5, but at least the highest alphabet is the lowest number. You see what I mean? So you basically just have those 2 rules. You just have to use them to eventually figure out carbon 1, and there's always an answer. So cyclopentane, 1 chloro, 2, 3, 4, 5 ethyls. And alphabetically, chlorine comes first, so it's 1 chloro, 2, 3, 4, 5 tetraethyl cyclopentane. Okay, any questions regarding why I chose chlorine? All right, you sure? No questions? Let's move on. All right, so the last naming example for the day, this one looks disgusting, okay? Well, that's because it is disgusting. You can still try to do this. Find the longest chain. Now, this might take a while. You have to stare at this for a while to figure out, hey, I think I see it. Longest chain is, I think, 9 carbons. You can either start from the chlorine or you can start from the bottom, the bromine. Which one is better?
The chlorine one.
The chlorine one, start from the top, okay? Because if you start from the top, you have a 1, 1. If you start from the bottom, you have a 1, 2. Of course, 1, 1 is better, so you start from the top. All right, so once you do that, you can start naming all of those branches. That's non-named, so 1 chloro, 1 chloro, 3 ethyl, 3 bromo, 4 bromo, 5 methyl, 6 ethyl. Wait, that's a mistake. That should say 8 methyl. I accidentally typed 6. And then finally 9 bromo. All right, so I know there's lots of different branches, but the rules don't change. It's just an annoying question. You might miss one on the test by accident, so that will be unfortunate. But on the test, I'm not going to give you this one. Like, this is too big for a test. I'm just trying to make you understand the concept. That's why I give you all of this. Alphabetical order when you put them together. Like, I see a bromo, that comes first. Chloro is next, ethyl, and then methyl. Okay, so you arrange them. 3, 4, 9, tribromo. 1, 1, dichloro. 3, 6, diethyl. That should say 8. So 5, 8, dimethyl, non-name. All right, do we have any questions? So this one is actually not hard. It's just annoying. There's a difference between hard and annoying. Hard will be what we're learning tomorrow. Alkenes are way more complicated. You good?
Yep.
Okay, so let's move on to drawing. Okay, so we've been naming from a diagram. You can do the opposite. You can have the name and you'll be asked to draw the diagram. Now, obviously on Google Form, you won't be able to draw anything, so it'll be multiple choice, but you still have to know how to draw. So 1, 2, 3, 4, 5, 6, hexamethyl cyclohexane. What is that? What does that look like?
Like a skeleton, but
Yeah, you always draw the skeleton, yes?
yeah, and it has like one branch like in every one of them, the skeleton.
Yeah, you draw a hexagon, right? And then a branch coming out of each corner like that. It's like a soccer ball. All right. You have to specify 1, 2, 3, 4, 5, 6. You cannot just say hexamethyl cyclohexane. Because hexamethyl, 6 methyls, it doesn't have to be one methyl on each carbon. You can have 2 methyls per carbon. So you do have to specify you have 1 on each, 1, 2, 3, 4, 5, 6. Okay, that's all you have to draw. If you draw, I prefer you draw the skeleton for your own sake. If you don't draw the skeleton, you decide to draw the Lewis. Well, I mean, good grief, you're going to have to draw all those hydrogens. And if you count wrong, you lose marks. So why would you do that? Just draw the skeleton so you can omit all the hydrogens very fast, very clean. The next one, cyclobutane. What does that look like?
Square.
Square.
Yes, that one is just a square. 4 carbons connected to each other in a ring, square. All right, so in geometry, that's a square. In chemistry, that is cyclobutane. Actually, geometric shapes have organic names. Okay, so this one, 2 bromo, 2 chloro, 3 ethyl, 3, 4 difluoropentane. You might think this sounds difficult, okay? The trick is you start from the end. Draw the pentane first and then just find all the branches, put them on the parent. So I'll give you 2 minutes, finish these 2, and then we should be finished. All right. So for the first one, it looks something like this, okay? You don't have to have the exact same orientation. So you could have it like, reversed. It doesn't matter. I happen to have counted from the left and I called that carbon 1, but you could have counted from the right. You could have drawn this vertically. So my point is there are multiple ways to draw this, but you must have the same structure, just viewed from different angles. That's fine, okay? So with that one, I have bromine on carbon 2, chlorine on carbon 2 because of 2 bromo, 2 chloro, 3 ethyl, so ethyl on carbon 3, 3, 4 difluoro, so 4 and 5 has a fluoro, and this is pentane, 5 carbons in total. So just make sure you check all the boxes. The second one, you have 1, 2 diiodo, 4 methyl cyclohexane. So I see the cyclohexane, so I draw a hexagon first, and then 1, 2 diiodo. It doesn't matter which one you choose to be 1. I happen to choose 1 on the right, so draw 2 iodines, and then a 4 methyl. So you just count to carbon number 4. Draw the methyl. Okay, again, I just arbitrarily chose 1 to be carbon 1. You could have chosen anyone to be carbon 1. It's just you rotate the molecule and you will get yours. Okay, is that clear? All right, so this concludes this lesson of cycloalkanes, so basically alkanes with a ring. To name them, very simple, add cyclo in front of it. Backbone for the cyclo is always the ring. And then alkyl halides, that's just halogens attached to alkanes, and you can only get that via substitution, and the naming rules are exactly identical. Okay? Do we have any questions? Okay, I'm going to end it then.